Welcome, everybody, back to the On with Shahan podcast. I have Greg Kushnir on the show today, all the way from New Zealand. Greg is a serial entrepreneur with extensive experience in the areas of deep tech, internet, and mobile. He's co-founded 8 companies, including his new venture, Emrod, and he's doing some really revolutionary work in long-range wireless power transmission. Thanks so much for joining the show.
Thank you for having me, Shahan.
Awesome.
It's a pleasure talking to you.
Thank you so much. So I'm very excited about this. I'm a huge Nikola Tesla fan. So when this came on my news feed, this certainly piqued my interest. And when you accepted to join the podcast, a bunch of people had questions, and you were open to answering everything, which I thought was so cool. So thank you so much for joining the show. So before we get into the cool stuff you're doing today, you obviously have an extensive background in deep tech. So if you could just walk through your background, what you've done, previous to Emrod, and what has led you to the work that you're doing today.
Okay. So the best piece of advice I ever got was find something that you feel that you're passionate about and get busy doing it. So that's pretty much how I got started.
Right.
I've got a passion for solving problems, essentially, finding solutions, and that usually entails using technology, but that doesn't necessarily the case always. Sometimes it's just finding a different business model. In terms of background, my professional, academic background starts with computer science, and most of the projects that I've done are related to that. But I don't discriminate engineering or sciences or
Okay.
kind of like all of that. So I was in the middle. My startup career started when I was in the middle of doing a PhD in philosophy, and sort of had an idea for a startup and had to make a decision. Academic life or the roller coaster of startups, and I took a wrong turn, I guess.
Yeah.
So that's in the way of background. Previous companies were also in technology and supercomputing, cloud computing, anything from apps to hardware.
Yeah. And then from there, like, how did you come about, that's kind of different than what you're doing today. Like, I guess hardware you were working on, but what led you to this idea? Was this something that you've always been interested in?
This is a culmination of a pretty methodic process that I've trained myself to do. So I've been looking at high impact technologies. So by high impact, I mean the sort of technologies that have the potential to influence the most people possible in the best way possible. So, I mean, all we have is, well, as you well know, all we have is our time, right? It's the most valuable resource we have. So I decided to invest it where it would have the most impact. When I looked, so I mean, there's very few themes that have a significant impact on society, on humanity. One of them definitely is energy. Obviously, it has been the pinnacle of civilization, pretty much how long, I mean, as far as you can see back, the access to energy, how you can easily obtain it, maintain it, send it, is pivotal. Fire is a form of energy. Electricity changed society. So when I specifically looked at energy, I realized that most of the work has been done in two sides of the energy triangle. So in generation, sustainable generation, last 4 decades, I've seen a huge development there. Then you have storage. And again, storage has come a very long way, especially in the last decade or two, driven by electric vehicles and so on. But transmission is sort of the forgotten son. Nobody's made a significant change in transmission in many decades. Many
Mm.
decades. I mean, essentially the same AC grids that's been introduced over 100 years ago. Obviously, with some changes, I don't want to say that it hasn't been changed at all. So when I looked at why hasn't it changed and what can be changed and what impact will that have on how we consume energy, how our access to energy, I realized very quickly that solving that part of the equation, going from wired to wireless, might have the same impact as when we moved with our phones or computers from uh, the constraints of wires to wireless. And the
Mm.
more I looked at it, it seemed that it's even more compelling because it can unlock things like significant increase in the uptake of sustainable energy. Right? You have, for example, many wind farm projects that fall through because of the cost, the capex cost of installing that transmission. Offshore wind farms is a good example, but there are plenty of others. So, and I've also looked at applications in aviation. Powering drones in flight means that they'll need to carry heavy batteries. You can suddenly have access to electric flight, to
Quick question there,
airborne
Greg.
platforms
So
that can stay there. Yep.
yeah, so I was thinking about that. Sorry to cut you off. A little bit of
Yeah, no
delay.
worries, no
Yeah.
worries.
So on the electric plant, I was thinking about that too. So could that technically mean let's think far out and assuming that it works? And I understand that, like from what I read, you have to have a line of sight, at least initially, to whatever's gonna receive the energy. But could you see a flight being or a plane being in the air for a very long period of time, or never needing to come down, if they were able to gain the energy from whatever systems you were able to transmit that energy to?
Much like self-driving cars, it is no longer a question of technological feasibility. It's a question for the regulator.
Hmm.
It is absolutely technically possible, and I'm happy to back that statement. But I don't think it will happen tomorrow because, as with any new technology that is going to be used around humans, you have to very rigorously test it in that sort of environment, and the regulator has to address it. How
Right.
can it be used? How it cannot be used? It was the same case with communication. It took a while. With powering electric flight, absolutely, we can do that tomorrow, but I don't think the FCC, in your case, is going to be happy to allow it before
Yeah.
being convinced that it's safe. And it's obvious. I mean, you've got communication systems on airplanes, right? You got to make sure that you're not disturbing them. You got to make sure that nothing compromises the safety of passengers and so on
Right.
and so forth.
Yeah, that makes sense. So before we get into wireless energy transmission, talk to me about traditional transmission of energy, and then talk to me about how wireless energy transmission is different and how you go about doing it.
Okay. So traditional transmission, I'm just going to talk about the medium, not the software, the technology of
Yep.
how do you manage grids
Right.
and load balance and so on. The actual medium, the actual pipe, is copper wires. Right? Sometimes it's used in higher voltages, lower voltages, depending on the application, depending on distance and the power levels. But essentially, it's copper wires. And it still is, I think, and will be probably the most efficient way to transmit electricity, at least
Hmm.
around for a while. The difference between between the wired and the wireless, is that the wireless opens up some possibilities and some economic value that is not accessible by wired. Um, there are two sets of these things that wires can do that. That wireless can do that wires can't. So, sorry, you were asking about the applications or the how does it work?
How does it work? And then we can get
Oh,
into
okay,
applications later. Yep.
sure. So in terms of how does it work, what we do is at the transmitting side, we take electricity, and that can come in various voltages and power levels and so on. We convert it into electromagnetic beams, specifically in the ISM band, so widely called microwaves. It's
Okay.
a very wide definition. It's shaped into a very narrow collimated beam, which is part of our IP, and it's a little similar to radar technology. So you can shape a beam to go over long distances in a focused manner. Then on the receiving side, we convert it back into electricity with a special antenna called a rectifying antenna. And that's pretty much it. I mean, there are no moving parts. That's the high scope definition of it.
So like Wi-Fi, like I would receive Wi-Fi, is it similar to that, except in this case, at least initial stage, the beam has to have a line of sight to the receiver. Is that correct?
Well, in some ways, it's very similar to Wi-Fi because it's using similar frequencies. However, it is very, very different in the way it's implemented. So while Wi-Fi blasts everywhere because you want the signal to get through, you don't care about loss of energy. In our case, it is a very narrow beam that preserves the energy, so there's no environmental footprint like you have with Wi-Fi.
Oh, that's very interesting. And that makes a lot of sense, right? You would want to conserve as much energy. That's kind of like reminds me of the AC/DC conversation as well. So that makes a lot of sense. So speaking of that, I saw a funny shirt the other day. It said AC/DC with Tesla and Edison, the two, just like the band. But I wanted to talk about this Tesla quote. And I wanted to basically know like what you're doing versus what he's doing. I follow a bunch of Tesla groups too, and they're very interested in anybody that's doing wireless power transmission. But he had a quote saying, "Power can be, and at no distant will be, transmitted without wires for all commercial uses such as lighting of homes and the driving of," he says, "aeroplanes. I have discovered the essential principles, and it only remains to develop them commercially. When this is done, you will be able to go anywhere in the world, to the mountaintop overlooking your farm, to the Arctic, or to the desert, and set up a little equipment that will give you heat to cook with and light to read by. This equipment will be carried in a satchel not as big as the ordinary suitcase. In years to come, wireless lights will be as common on the farms as ordinary electric lights are nowadays in the city." Nikola Tesla, The American Magazine, April 1921, almost 100 years ago. So, Greg, what took you so long? So I just wanted to know, like,
no pressure.
I don't know if you've studied his research. I'm assuming you've seen it, but like, what's similar? What's different? Are there any learnings you took from Tesla?
What a visionary genius, right? Just the ability to vision these things when there was nothing in his environment to suggest that it would be possible one day. It's it's the sort of giants like Tesla and Jules Verne and further back, Da Vinci, that we stand on their shoulders. They provide inspiration. They open up a window for us to look forward and think, well, wow, if that would have been possible, here are the benefits to humanity. So that's definitely a motivation and a drive, and it has been and still is for me.
Right.
However, when it comes to the actual technology, unfortunately, I have to say that the physical effect that Tesla wanted to harness, those ground waves, has been examined very closely over the last 100 years, and unfortunately, using the technology that Tesla has envisaged would not lead to what he hoped it would. The reason is that the generation and moving of energy these days is a business. Business has to make sense economically. Tesla's systems unfortunately harnessed an effect that would make it very, very inefficient. So while in very perfect conditions, you can harness it to move energy over very long distances, the efficiency of that would be uh, dreadful, highly uneconomical. That's one thing. The other thing is we're very conscious of environmental impact these days. Can you imagine the impact of moving all that energy through Earth? Has to be studied, let's put it mildly. Mm-hmm. So Tesla is definitely an inspiration, is definitely a motivation, but the technology that we were using is very, very different. And to answer why now, why it took 100 years, radar has been invented in the middle of last century, just a little bit less, Second World War. So that bit took a bit of time. Then the other bit of the equation, which are advanced materials or metamaterials, this is really a relatively recent development. So they've been around for a few decades, but the development of the increase in computation power allows us to design smarter and smarter materials because we don't have to build them, to test them, can model them. Right. And that triggered a leap in capabilities in those materials, traditionally used for, stealth technology, essentially, absorbing some energy and doing something with it. So it took a long time because those sets of technologies had to mature to a point that makes them economically viable, essentially. And we are at this point.
Yeah, that makes a lot of sense. So now, so the article that I read, I believe you're live in New Zealand with you're working with one energy company currently. So are you testing right now? Are you live at the moment, or is it a pilot? Do you have any information you can share with the work you're doing today?
I can share some information. So we are working with the second largest electricity distribution company in New Zealand, and the next system that we're delivering to them in a couple of months is definitely a significant improvement on the previous one. It's the main aim of the next system that we're delivering is to appease the regulator that it works in the environment just like we say it does. All the safety mechanisms work. There's no environmental footprint and so on. Beyond that, there are field trials. PowerCo is not the only company that we're discussing field trials with. There are a few field trials that we're discussing at the moment around the world. But I can't say more until
nothing you need to share that's extra. But I did have a question. A previous guest too. I asked for questions. He asked, "Will it ever be in the U.S. or in L.A. specifically? We have rolling blackouts here, so this would be perfect for the U.S. market." But to your point, like it's up to the regulators, and I can imagine that's going to be quite difficult to get through.
Well, at the moment, there's nothing in the regulation, in the law book that prevents the deployment of these systems. However, FCC is pretty active. So once it becomes a thing, an option out there, I'm sure that they will want to address it. We are looking at a pilot in the US. But I can't share the details until it will be finalized.
Okay.
It's especially interesting during work, right?
That's very promising. We have blackouts here all the time, and I'm hoping it's in California first. So on that piece, like in terms of like health risks, so walk me through why this isn't going to electrocute me, or why am I not going to be really messed up because I'm in the line of sight of this? Like, how does this work?
Okay, so when you go down to the basics, it's not very complicated. The physics of it is pretty basic, and it's easy to see why the impact and the health and safety issues are easily addressed. So if you're talking about energy beaming, the main thing you need to look at is frequency and power density. These are the two things that govern the impact on organic tissue. So The frequency that we're using is within the industrial scientific medical band, which is unlicensed. The impact of these electromagnetic waves has been very well documented, deeply studied. So there's a good body of knowledge about the impact of those on animals and humans. We know what to do, what not to do. So one advantage is that these sort of beams, the impact that they have is mostly heat. They can't punch a hole through things. The waves are relatively long. So the other thing is power density. So the power density is how much power you have per say square centimeter, square meter. In our case, we make sure that the power density is relatively low. So even if all the safety measures have failed, and I'm happy to share some of those, even if all the fail-safe mechanisms have failed and say a human or a bird or a helicopter walks into the middle of the beam, the impact is not very significant. That means that with the power density that we use, someone will need to linger in the middle of the beam for a good few minutes, probably 10 minutes or more, in order to feel any measurable impact, and that would be an increase in the heat. So that's pretty much it. So beyond that, we have obviously safety mechanisms. I'm not going to go into the details of all of them, but some of them are pretty standard, like using laser technology as safety curtains. So anything that is coming close to the main beam means that the main beam is going to be switched off. So the beam sees nothing but clear air. Let's put it that way.
And are you going to have like rods or something in different parts of, whatever land you plan to beam energy? How do I receive the energy? Like from you? Is there a rod on the top of my house or somewhere near me that and then my energy is tuned to some frequency and I'm able to receive that energy? How does that work?
So both the transmitting antenna and the receiving antenna look a little bit like a flat screen TV. It's a flat rectangular shape.
Okay.
It's a technical terminology, it's called a phase array. So there's a whole lot of small elements which are controlled by a computer. So they are synchronized. The receiving side is similar in shape. So it's not a rod, it's a something flat panel. And you don't have to tune it into any particular frequency. It does it by itself. It's essentially, I think it belongs to a category called metamaterials. So these are materials that once they absorb some sort of wave energy, they do something with it. In our case, it's converting it back to electricity.
That makes sense. So you have obviously a big hill to climb with you're changing pretty much how the whole game is done, which is amazing, and I find it very inspiring. So how do you win? How do you go about doing this? Do you prove you take that first win and then you work to prove that out? You run, I guess, tests to make sure it's healthy. How are you thinking about winning this battle? Because it's a very difficult thing that you're going up against, obviously. But how do you see yourself and Emrod succeeding in this environment?
I think that most of the stakeholders are not our enemy. We're not going against them. I think one of the best things about it is that we're actually providing unlocking a whole lot of new value to stakeholders, like, for example, electricity distribution companies. So it's not so much a battle as a convincing campaign,
Gotcha.
to demonstrate how does it bring value to those different clients. In terms of go-to-market strategy, so we're starting to work with electricity distribution companies. That's the low-hanging fruit, and that's exactly to address what you've mentioned. We got to get that initial success, initial traction, and we can't do everything. A startup has very limited resources,
right?
And it's so that's where we're starting. But in terms of where do we want to see it and how we get there, we see quite a lot of applications in aviation, in shipping, in the space industry, and in other verticals as well. We're not going to address all of them. Our plan is to license our technology to various significant players within those verticals.
Hmm.
And that's how we hope that our technology is going to get traction, as wide a traction as possible.
And when you say like we view ourselves as complementary to like the current players, is that because of your technology? Like one of the things I was reading on the website, it's like remote areas, maybe they won't even have access to serving today in the given infrastructure, things like that, offerings that they don't have today. Is that how you view yourself to the current incumbents?
That's certainly part of it. So the two parts are to the value that we provide. One is exactly that. So providing electricity transmission where there are no other alternatives, which is the category that you've mentioned. The other one is doing the same things but better. So, for example, if we can help electricity distributors to replace the edge of the grid with something which is easier to maintain, more economical, more environmental, they're happy to jump on it. It's just a matter of demonstrating that it's safe, that it's after regulation and so on. It's not necessarily just in the case of remote places, but that's certainly a very compelling use case.
Yeah, and it's a good initial use case. Yeah, it makes a lot of sense. So on that front, so like let's say the end game, this goes mainstream. How does the world change if Emrod is able to do what it needs to do?
So it's a very good question. So we hope we can see the following changes, or hope that the following changes will take place. One is prosperity in places where traditionally prosperity has been held back by access to energy and communication. So remote places. We're talking to companies in Africa and in India and so on, Pacific Islands, where prosperity has been held back because they don't have access to significantly cheap energy, right? Before, I mean, there's a lot of talk about bringing internet everywhere. Well, before internet, you have to bring some power,
right?
To power. So that's definitely something that we'd like to see: more prosperity, more democratization of that prosperity. Other things that we would love to see happen is the uptake of sustainable energy. There has been a lot of friction in the introducing of sustainable energy. So although there's a lot of push towards it, it's still governed by the economics, right? Just recently, governments stopped subsidizing solar farms. In many places, they still do. So while there's a large push, the cost of transmission has held that back. We hope that by introducing a more cost-efficient way of transmitting that energy will support the uptake of sustainable energy. So we'll see more wind turbines, more solar farms. Harvest that energy where it's abundant and transmit it efficiently to where it's needed. You can think of it on a small scale. I've got a farm and I want to put my turbine up on the hill, but I don't want the cost of a cable. But you can also think about it in a large scale. Places like North Africa, Saudi Arabia have a lot of sun, but not a whole lot of demand for that energy. If you can transmit it wirelessly over large distances without interruption, hey, there's a lot of consumption in other places. So that's one. Some of the things that we would love to see. Same goes with electric vehicles, electric ferries, electric aviation. But having said that, what actually makes us more excited is the things that we don't see. And I explain what I mean. You know how with internet and other transformative technologies, the creators have a set of problems that they mean to address. With the internet, DARPA wanted to solve, to create a indestructible communication system to survive nuclear doomsday, right?
Right.
But obviously, they haven't thought of social media and so it's only when those technologies are out of the creators' hands and in the market, and they start getting a life of their own, and people start thinking, "Oh, hey, I can use this for that." This is when it gets really exciting. And the more we talk to people, the more we find out about use cases we haven't thought of. Fish farming in the ocean. I mean, there's powering underwater drones.
Mm.
There's so many applications that we can't think of, and what keeps us really excited is we want to bring it to the world and start seeing those things.
Yeah, that's amazing. Like I was even thinking of like sci-fi type things of why couldn't you have like a floating hotel if it had unlimited energy stores? I know that's way out there, but I was thinking of things like that and how if we did have wireless energy, I think the whole city structure would be completely different, right? There's so many other things that you could do. You could be more efficient. There's just so many things that just don't make sense. So I love the work that you're doing. In terms of my work and the work that I'm doing, I help startups launch their business. And when I hear stories like yours and the mission that you have, it inspires me even more to have bigger goals. And I'm all about the mindset of when you think big, you think even bigger. So I just, if you wouldn't mind, if there are new entrepreneurs out there, I think this is your eighth or ninth company that you're working on. Do you have any advice for new entrepreneurs that are thinking about tackling something big? There's something about your mindset I think that people can learn from in terms of like, hey, this is a huge, massive undertaking, but if I go about this in a structured way and I think about it and iterate on it and figure it out, there is a way to look at that big goal and reverse engineer backwards all the things that you need to do. Obviously, you need to change and pivot as you go. But do you have any advice for new entrepreneurs that are thinking of a huge goal for their life?
Thanks for that, Shahan. Look, I think that, and I've mentioned it before, the most important resource that we have, that entrepreneurs have, really the only thing that we have, if you think about it, is time. Now, before committing to any project, especially if it's a huge undertaking, I would suggest to any entrepreneur to have a very good look, to examine thoroughly, is this something doable?
Hmm.
And if it is it worthwhile doing? Which is a completely different question. Not
Right.
everything that's doable is worthwhile doing. If you've answered both of those questions with a affirmative, after giving it some good thought and consideration, if it's both doable and worthwhile doing, surround yourself with good people
Hmm.
and get busy doing it.
Hmm.
It's a series of small problems that you need to solve. You don't need to solve the whole thing in one day.
Right.
It's one thing at a time. Eventually, you'll get there, or not, but at least you've tried. Which is, if you don't try, you definitely have failed already.
I love that. That is amazing advice. Greg, is there anything that we missed that I didn't cover here that you want to cover? And I also wanted to make sure that if there's any that way that we could follow you and the work that you're doing, visit your website. Maybe there's a newsletter. Just plug anything, anything that we missed, and/or any ways that we can follow you.
Thank you, Shahan. That's very kind of you. I will definitely keep you in the loop. One of the most important things with a venture like this is winning hearts and minds. Just spreading the word that this is available, that this is possible. Starting a conversation in different places. So, in a way, you're already contributing a whole lot to this. So, thank you, and I'll definitely keep you in the know.
Awesome. Yeah. And I'll definitely connect with you offline of some resources. And I really wanted to say, I really appreciate you coming on the podcast. And thank you so much for joining, Greg.
Thank you, Shahan.
Awesome.